Well, hi, good morning, and thank you so much for joining me in my shop here. It's June 6th today. Today is the 80th anniversary of D-Day in France, and that's a very important date for me. My father was in the Second World War. He landed in France on D-Day, and in fact, he landed with the Canadian soldiers on a beach called Juno Beach. He fought with the Queen's Own Rifles. And he was in one of the first 10 boats to hit the beach. So the very, very frontline shock troops. My dad was part of that. My dad had to run across the beach. It was a very, very wide beach. The tide was out. Guys getting shot around him. Mortars and bombs falling. And somehow he managed to survive. He fought for another year. He was in Europe for a year after D-Day, fighting. So I didn't know anything about this. I knew my dad was in the Second World War, but he refused to talk about it. He was not interested in talking about it. Anytime I did ask him, the few times I asked him, maybe we'd be watching a movie, "Dad, was it like that?" And his only answer was kind of the same thing every time. "It was a long time ago, Jim, I don't remember." That was kind of what he would say. I really think what he was saying is, "Jim, I really don't want to remember what I went through." So the only way I really know about my dad's experience is because another soldier wrote a book. Wrote this book here, Battle Diary. The soldier's name is Charlie Martin, who wrote this book. And that's a depiction of the landing. But this is an artful depiction. In reality, these individual boats were hundreds of meters apart, spread down the beach. So each boat kind of landed on its own, kind of by itself. There wasn't a big crowd of men coming off these boats and going across the beach. There's a thin string coming off of each one. It didn't look like this. And the beach was not like this. The beach was hundreds of meters long. It was a huge killing zone here to get across. And then you can see in this picture, it's accurately showing some kind of a wall on the far side of the beach. They had to get over there. You can see some soldiers trying to climb over it there. And this building here, this is a famous building, still there, on this beach. This is called Canada House, because this was the beach that the Canadian soldiers landed on. 400 men in the first wave for about 45 minutes alone. The 400 men, something like half of them were killed or wounded on the beach. Maybe not quite half. As D-Day goes, there were a lot of bad places to land, of course, and be killed or wounded. The Queen's Own Rifles was one of them. Some would say the worst. This was the worst place. My dad landed in the worst place and managed to survive. The guy who wrote the book is this guy here, Charlie Martin. Here he is here. Look at this. Charlie Martin. Can you see the gun in his belt? He's got a gun. He's got a pistol in his belt. And this other soldier here, that's my dad. That's my dad right there. This is after D-Day. They're somewhere in France. I guess obviously they're smiling. They're not. There's no battle going on right at that moment. So this book details. There's that picture again. What's it say here? Lindy Lindoness. Yeah, my dad's nickname was Lindy. Lindy Lindoness, Wright, and myself, likely at a time we were sharing a slit trench at Grenfell. So, yeah. My dad landed on D-Day in the first boat. It was a shock troop. Had 3 years of heavy training for it. He was 20 years old. And I think, well, there's no doubt, that shaped my father and shaped my life because of the father I had after that. Okay, before I get a little too emotional, of course my father passed away a few years ago. He lived to be 92, so he lived a long life. Played a lot of rounds of golf. Many, many, many rounds of golf. Okay, so I'm going to stop for a little bit and then we're going to get back to tracing signals through this radio here. So one of the things I checked yesterday on this radio quickly was the antenna link on the antenna connection at the back here. What I did was I just kind of leaned over and looked at it and saw that the link was there, but I didn't really check it any closer. Last night, after getting an email hinting that maybe this link isn't working here properly, I came in and I found the center screw here backed out like that. Now, my experience with these kind of connectors, screw down connectors, is if the screws are loose, often the contact is terrible, even non-existent. So that's the regular antenna. This is the ground up here, and this is the, if you're going to use a balanced antenna, you would remove the link and put the balance on here, the balance leads, antenna leads here. So what was this not closed properly? So if the ground wasn't in place, then this is what would happen here, or what would not happen. So you have the signal coming in on the antenna from here and going to one of these coils selected by the band switch, coming out of the coil, and it's heading to a wire that should be grounded to the chassis. It's done through the link. So if the link is not making contact, the ground is missing, and the signal won't work its way through these coils properly, and you just won't get much signal moving forward into the radio. This is really square one. I think yesterday I was complaining I couldn't get past square one, but in fact I spent the whole time past square one. Here's square one. So now I fiddled with the screw, so I kind of ruined my chance to find out if that was really a problem. But we'll fiddle with it some more here. Let me loosen it off, in fact. Well, yeah, just loosen it off like it was. And we'll play the radio, we'll play a signal into it, and we'll see what happens here. Okay, let me just get everything warmed up and operating properly. Okay, I think I've got it running. You can hear a little bit coming out of the speaker, some clicking noises. So I'm going to tune the signal generator, tune the radio, and the radio is currently tuned to, it says 1200. That's odd. 1200. Here we go. $1,200. It's a mile out. So very severely overloading the radio with the signal here, but that shouldn't happen. This radio should be able to handle that kind of signal. So that's all part of what's going on here. I have the audio full, the RF gain full, everything is full. Very little chance that the kind of behavior has something to do with that screw on the back. That's just a fat chance on that. But let's fiddle with it. First of all, I'll wiggle it around. Nothing too exciting happening here. Let me just do this. It's just there's nothing. I'm getting nowhere here. I'm going to tighten the screw down. What if I take the link right out? Let's take the link right out. That's the thing to do. Link out. Link in. Ain't no difference whatsoever. What's ahead of that? How can this be the case? Or back to open coil and stuff like that. Let's go up to the next band here. Okay, next band. How do you like that? So that did make a difference. Before I tightened the screws down, the sound level was low, the noise was low. Now it's much higher. Let's tune something in on this band, see what it sounds like. So on this band I am tuned to 4 megahertz. Okay, 4 megahertz. Let's see, listen to that. So that really sounds like a terribly biased tube, or a tube missing its bias or missing its B+. Is it really worth even going any further with this? Of course, that's what I'm hearing at the far end of the radio after all the stages. If I use the tracer, we can listen and find out where it goes kind of wonky. So I know where the plate is now on the first RF tube. Let's just go and check this out. Now I got to think for a bit. We got to go back to the 1 megahertz deal here. I think there's nothing especially wrong with band number 1. It has the same kind of bad distortion. Just whatever's wrong is worse on band 1. That's what I think. Gain is up. And we are going to want to go right on the edge of it here. Don't know why I want that there, but I do. Okay. We can't be listening to the speaker though on the radio. That's an RF gain. Let's leave that one up. Audio gain down. Okay, now, so we're trying to pick up that exact frequency. So we're gonna go to the antenna here. I can't get to it. Just an inch too short on the lead. Which one it was, Jim? Do you remember? No. I don't remember which one it was. Wasn't it 2? Oh my gosh. I mean, a whole day has gone by, so that's my excuse for not remembering. After a whole day, it's pin number 1. And the plate is 5. So 1 is the input. 1 would be here. Hello? Where's the signal generator? Okay, right on the input from the signal generator. Tuning in my tracer. Okay. Going to the grid of the first tube. There's nothing there. Wait a minute, I thought I found it there last time. Okay, what's coming out of the... Wow, this is just... It is a little hard to believe. It's pin 1. It's definitely pin 1. Pin 5 is the plate. 1, 2, 3, 4, 5 is 5. Okay, something's going wrong here. Something not right. Something's not right, Jim. This is no good. better. So this is the audio gain. Breaks into oscillation at the top. Needs to be at the top to be heard. Okay, let's just, why don't we listen to that volume control? See what we can hear from it. Okay, we're going to do that. So I'm going to switch my signal tracer to audio. What we'd like to hear is that tone loud and clear on the input to the volume control. The input to the volume control is among all these wires here. I can't really see in there very well. Let me see if I can spin this around. Maybe I can hear a cat crying. Okay, there we are. That's the volume control there. I can see it much better. So we have an input side, and one side's grounded, I can see it, so the other side must be the input side. Be it right here, hand on the volume control. There we go. That's what's there. There's nothing there. There's nothing. That's a little weird, isn't it? How come I can't hear it on my So you're hearing, what you're hearing is coming out of the speaker that's attached to the radio here, not out of here. How can this possibly be? This is definitely the ground here. Yeah. This is definitely the input. Okay, if I turn it way up, you can hear some of the signal. So that's telling me the weak signal is all the way to here. It's weak at that point. Let me turn this down here. So the weakness is ahead of the volume control. There's a lot of stuff ahead of the volume control. Somewhere between the antenna connection and the volume control, there's a problem. Maybe even more than one. So I still don't have the impression that the signal is getting anywhere into this radio. I got the impression it's still hung up somewhere right in the very doorstep here. And why do I think that? Because if I take my signal tracer, stick it on the input, okay, let me turn this one down. So you're hearing the signal tracer. Okay. That signal travels through coil, a transformer, shows up here. I don't hear any signal. So either I've got this tube figured out wrong, and well, interestingly enough, now the calibrator is right here. And the calibrator circuit is, this is the calibrator plug here, and it's hooked up right to the antenna. So pin 3 of the calibrator is right on the antenna. What if I just listen there? What if I pulled it? What if this calibrator is causing the problem? Calibrator switched off right now, so The tube doesn't have any high voltage there. I can't imagine it would do anything. What am I doing here? I'm just fishing. I'm going fishing. So the calibrator socket is here. There's a wire going right, oh, straight from this capacitor. I can see it. So if we go there, where'd the tone go? What happened to my tone? Oh, wrong spot. Okay. And that ticking you hear coming and going, that's some weird interference. I've never been able to figure out what it is here at my house. You hear that volume? Might be the same. Okay. From here it goes over to the grid. There's nothing there. So there's got to be something. I got to be doing something wrong here. Got the wrong tube, or I've done doing something stupid here. So I'm going after V1. V1. Looking at this, V1 is here. V1's here. So this is the back of the radio. This is the front of the radio here. So it's a tube towards the back in this row near there. Tuning is done here. These are the 3 tubes in a row. The V1, V2. I'm after V1. Yeah. Turn it around the right way, because it would look like this. So V1 is sitting here towards the back near the socket to the yeah, there's no, okay, that's definitely V1. Okay, so I haven't got that wrong. So that's V1. So V1 sitting here. When we listen on the grid connection at pin 1, we hear nothing. Yet somewhere back in here we can pick it up. Somewhere between here and here. What is there? There's that capacitor. That capacitor, that's about it. So I need to look on pin here, find this resistor, 22 ohm, find this capacitor. Don't forget the radio's switched on. So I'm looking there. Well, I don't think I was looking at pin 1. I think I got the pin number wrong here. Let's go back around this way. Here. Oh yeah, I got the pin numbering wrong. That's what's going on. Okay, let's try this correctly now. So I'm basically getting back to where I stopped yesterday. That's what's happened here. So pin number 1, just a little awkward to get to. Hand on the volume control. There it is. So that was pin number 1. Now pin number 5 is the plate. 1, 2, 3, 4, 5. This is the plate here. There we go. It's amplified. So leaving the tracer alone, that's the plate. That's the signal there. The plate. A lot of humming with it, but I think that might just be artifacts of how I'm doing the test on that. So there we are. So it's made the signal gets through the first tube. Then it heads. Oh my gosh! Then what is going on here? So the plate. What is all this? This is these are the local oscillator. Just you have a variable oscillator here. You have a crystal controlled oscillator further on. This is just all front end fanciness, but actually after this too. Well, I don't really know what they're doing here other than just some tuned circuits. Switching in the coils, signal coming out, yeah, and heading for the next tube. We have to go to the next tube, past all this stuff, and it didn't show up on my diagram here properly. Okay, so I'm going to look into that next tube. Where's the grid and the plate, and we'll check the signal passing through there. Okay, turns out the next tube is the next one in line here, and it's the same pins. 1 is the input pin, the grid pin, and 5 is the plate. So looking now, so I do not make the same mistake and get the pin numbering wrong. Hand me my flashlight. Here it is. Easier said than done, figuring out which one's pin 1. Okay, so pin 2, they've bent it right forward into the center of the tube socket and soldered it to the center post. And pin 3 looks to be the same. So that's not going to show up on here, is it? Pin, I can't read the numbers, can't see what's grounded. So I'm looking for the gap, you know, the missing tooth, so I can count these properly. Well, I think that's pin 1 there. He says pin 1. Wow, I can't get at that without. Who's talking to me there? So we want to hear this on that pin. Is there some easier way for me to get at it here? What is going on there? Wow. I don't know. I don't think I can get in there. So if we leave that as 1, go 2, 3, 4, 5. So the plate is here. Let's just skip to the plate. This would be the plate here. And on the volume. Don't hear a thing. Back on the plate of the previous tube. Plate of the next tube. Wait a minute, what's that next tube doing? Is that just, what is that? It's a mixer tube. Oh. Oh. So this is the tube that's going to do the first conversion, and the rest of the radio, the next part of the radio is tuned to 1650. So vocal oscillator coming in there, and why wouldn't we hear this anyway? I wish I could get the grid now. I mean, the two tubes are side by side. How come? Why the diff? Why is it tricky? So the plate. Oh, a plate goes into all this schmozzle in here. That's right, the big schmozzle. Yeah, the one tube feeds into the schmozzle. Then out of here it comes. So something going on in the schmozzle. And I do signal tracing on another band, except my signal tracer is restricted to this low frequency broadcast band. I cannot trace higher frequencies, not without doing some other technique. Well, I got to get on that grid. We got to get on the grid. We got to get there. Turn the lights up in the house here. Yeah, all the wires I see in the area, none of them are the ones I want to touch. I just want to go in and touch the terminal there. Wow. I don't want to short anything. That's it. That's the grid. Really? It's just nothing. There's nothing there. Okay, output looks like this. And what's arriving at this next tube? Careful, man. There's nothing. Am I really touching it there? There's no other way into it. Is that really pin? That's pin number 1. Without a doubt. Or is it? Without a doubt. Let's just flip on this voltmeter here. Probably what I'm going to do is I'm going to revert to checking voltages through the radio next and give up on the signal tracing thing, which is just not going well at all. So this is my voltmeter. Way to go. Okay, voltmeter. It's this one right here. Turn my light down because it's too bright for me. This guy here, 500 volt scale, positive. So if we start with a filter capacitor, power supply filter capacitors, you see almost 300 volts showing up there. So that's 250 there. 280 here. That sounds just about exactly right for this radio. So now we come up, we look at the plate on pin 1 or tube 1. $130 volts. Offhand, I don't know if that's correct. Something there anyway. Plate here. This is the one I really want to find out. Is this really a plate? Oh yeah, there's the voltage. Is there a screen in these tubes? Yes, there is a screen in both of these tubes. attempt to find the screen in the tubes just by going around. That's a plate. It's pretty low. Plate. And that's probably the screen, much lower yet. That's 90 volts. It's pretty low, not necessarily wrong. That's probably the screen there. Yeah, I think so. I think there's a screen and a plate voltage. Plate voltage is very low. Let's see what it says here. So if we I don't think it's going to say anything. We trace this back, looking for anywhere where it's going to say what it is, and then it goes into the schmozzle. How does it get there in the first place? So the draftsman has heavied up the high voltage lines. There's a 270 volts here, and there's a connection there. They didn't draw the dot very well, but that's connected. 270 volts. You have a main bus supplying 270 volts. So for instance, the plate voltage here, oh, that's a screen. Oh, I want to look at this one here. The second tube plate voltage is on the 270 line. So we should see 270 volts on the plate of the second tube. What's going on in the first tube we can't tell. 270 on the second tube. I don't remember what I saw there. So second tube plate. A 200. We're not at 270. But over here, 250, 280. How to get down. And can we really drive this first tube again? Because of the B plus has got to get to the plate on this line through all this stuff. Hey, what if I change the band switch and watch the B plus? And we're switching in different components here. Maybe get a different result. And I'm just fishing here because I really. Okay. So we'll take a reading. This is a plate of the first tube, and we get to 130 volts. Change bands. Much the same. Much higher that time. Much higher that time. So this setting we're getting, oops, 180. Seems normal to me. That would strike me as being normal. We're fishing in the wrong pond. No signal on the grid getting here. Find that capacitor and get on the other side of it. Find this point C. Oh, there's a test point right here. Point C. We gotta find this anyway. Excuse me. Point C, is it underneath? I don't think it's underneath. think I remember seeing it up on top here. Alignment point C. And they're pointing at the something right here. So this is the band spread tuning, and this is the main tuning. I think you're going on this band spread tuning terminal. Which would put you right on the feed here. So we get a look at what's coming out of the schmozzle circuit. How do you get at that now? I got the radio upside down. Okay, stop for a minute or two. That's how. Okay, so I think we're looking right at that terminal there. So the idea of this is to listen at that terminal. What do we hear? What do we hear? It's kind of there. I'm tuning the radio. All this time I've been doing this, the radio's not been tuned. You dummy. Dum 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 dum. Of course, you can't hear things that aren't tuned in. Dummy, 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 dummy. Well, that's pretty good. Okay, I think now that's after the schmozzle, before tube number 2. And now I'm going to look at this radio. I've turned it sideways. Oh man. Am I going to know what I'm looking at here? So again, we want to go on the... Oh, I'm all turned around now. Where am I? One, two, three tubes up there. I can't even get at them. They're just the angle is so bad for me to see and everything. Oh my gosh, I'm all over the map here. What did we just find out? We just found out that there appears to be a good signal. We found out I didn't have the radio tuned. That's what we found out. So we should really revert back. Okay, let me lay this down. You get the impression I don't have a clue what I'm doing? Oh, I have a clue. I have a clue, all right. Okay, I just don't like moving radios that are plugged in, but I'm going to do it. Okay, that one. Okay. Okay, you can see once again. Now we're tuned in. I like that. That's the plate of the second tube. Signal's there. Okay, we made it another tube. Now things are going to get more difficult, because what happens now is the radio is going to convert the incoming signal, the roughly a million I'm feeding in. It's going to convert it to 1650. So I got to try to hear 1650, perhaps at the grid of this tube, or even the plate. We can skip right to the plate. So pin 5 of V4. V4, is that just simply next one in line? V3, V4. V4 is there. V4 would be 1, 2, 3, 4, right here. This is V4. A lot of heat coming up out of this. Like there's a lot of heat right in here. Okay, maybe the transformer. Oh, son of a gun, that transformer is hot. Oh boy. Okay, quickly, emergency. We have an emergency on our hands. This radio is sucking back the power. I didn't notice. Okay, so the transformer is 50 degrees. 60, 70. Oh my gosh, I'm hitting the tube sockets. Don't get carried away. The transformer is 50. That's pretty hot. Hotter than I would want. The watt draw on the radio right now is how many watts? Okay, 70 watts. How many watts are you supposed to draw? Does it say somewhere? How many watts? It says 85 watts. So I don't know what to make of it. The transformer runs hot. Okay. Emergency's over. Back to what we were doing, which is attempting to hear the signal on the next tube plate, which was 5, which was also plate 5, only we're trying to hear it at 1650. Okay, 1650. Let's just turn this up. I don't hear anything. Why not? Don't turn that. Turn this. Hello? Hello? What's happened here? What did I do? I'm hearing nothing at all coming out of this radio now. Okay, we'll just ignore the radio for now. Next tube plate is 6, 5. 1, 2, 3, 4, 5. The plate goes straight into a coil. Plate goes straight into a coil, right? 1650. Don't forget that. Okay, this may not work at all. Let's try it. So I'm going to go on pin again right here. Yeah, that's 1650. Well, that sounds nice. So we found the signal now all the way to the start of the 1650 IF circuits. We go a little bit further along. So we're going to this next one. Next one is the next mixer at the grid. It would be pin 2 of V5. Pin 2 of V5. Okay, V5 is located V5. It's located in the last place I'm going to look. Here it is. V5 is here. So we've done 1, 2, 3, 4, 5. We're just going the next one down. Next one down is right here. It's got a big right. It's got the crystal on it. So I want to do the grid pin of V5, which is 2. We should find 1650 pin 2. 1650 pin 2. Okay. So we're tuned to 1650 still. Oh my gosh, I'm going to spot pin 2 on this thing. Well, it's just They don't get much busier than that. That's this guy. Yeah, he's got a pin 2 in there somewhere. So I'm trying to spot the gap in the. I think I see it. So that would be 1, or that would be 8. That would be 1. If that's 1, then oh my gosh, 2 is wire. Oh my gosh, 2 with 2 doesn't have an actual connection on it, does it? 2. What do you say about that? Okay, trying not to forget. The radio is turned on. Yeah, how's this going to help? So I think I see the gap. And then this big resistor here appears to be on pin number, that would be 1. That would be 1, and the next one over would be 2 down in there with this this capacitor on it. No. This one. No. No, there's a wire coming out. Yeah, going over to the transformer. That makes sense. So that wire from the transformer secondary is what we want to touch. That wire coming over from the secondary. Some bad things can be happening here. As soon as I touch it, I may be detuning the. I don't hear anything though, eh? On the input side. Okay, so there it is on the input side. On the output side. Here. So one of 2 things is happening here, or one of 16 things is happening here. One of them could be I'm just detuning this when I touch it. So if I make this as sensitive as I can, and just hold it up close, hear it? Now if I hold it up close on this side, nobody. So I'm trying to pick up the signal without... So it looks like the output of this transformer not there. Not there. That's what it looks like. Well, what do you do about that? Turn this down. The interference is there, but the signal is not. The signal is back here. Fairly clear. Signal there. I'll show you exactly what I'm doing here. I think I found the dead ender. It's not particularly good news either, if this is the case. Okay. So, coming into this tube from this transformer is this signal. This is on the primary side. Now we go over to the secondary side. This is what we hear. Nothing. Like really nothing. Okay, if I crank up the sensitivity here and just get close, you can hear it. Ooh, touched it. Go on the other side, nothing. some funny clicks and stuff, but that could be anything. Okay, so I'm going to shut this right off here. Shut off my tracer. I'm going to shut off the radio too. Well, okay. So if we were to accept this observation, what I'm saying is the transformer here is defective. That's a sad, sad, sad finding. That's a really sad finding. So I don't want to find that. I would rather. So I think what I'll do tomorrow is I'm going to focus on this transformer, try to prove its functionality or its lack of functionality, and maybe it's almost the end for the radio, unfortunately. I mean, look at this, all this stuff going to go to waste because of one little coil here. And the more I study this radio, the more I realize that this has got some really interesting circuits in it. Not to go over this in detail, but all this stuff up in here is all part of the bandwidth control. These are the controls here, switching in different combinations of filtering, and it's just really cool, but out of reach at the moment. Wow. That's the name of the game. Is that transformer good? Would I ever have a replacement for it? No, because this is a 1650 wound coil. And if it was a 455, I got a dozen. I got a dozen brand new IF transformers that could be jammed in here. But it's not 455. Okay, well, that's a little bit of a sad situation there to end up on. But just thinking about my dad made it across the beach. He didn't stop then. It kept going. And I'm going to keep going too. Thanks a lot for watching, and this is a tough one.